When we're talking about quantum threats, quantum attacks to Bitcoin, we're talking about a quantum adversary being able to basically steal someone's private key.
When is Bitcoin going to zero because quantum computing will break cryptography?
The elephant in the room is that there is.
The issue of quantum computing breaking cryptography has remained an existential risk for all of blockchains since the beginning of Bitcoin's early days. So what's next? How can we protect, by we I mean engineers and investors in the crypto space, protect our holdings and investments from the inevitable? We're talking with Chris Tam, director of BTQ Technologies. That's BTQ on the NASDAQ. Their company is working on exactly this issue. Welcome to the show, Chris. Good to see you.
Thank you for having me, David.
Let me just start with the heart of the issue, Chris. When is Bitcoin going to zero because quantum computing will break cryptography?
That is a hell of a question. And if I had the oracle, believe me, I wouldn't be telling you. There are, I think there's a bunch of different ways to look at this. The elephant in the room is that there is, quantum computing exists. This is something that Satoshi Nakamoto didn't account for in the beginning of building the Bitcoin protocol. Is something that he actually acknowledged a couple of years later. And, fast forward to present day where we have this very decentralized network of engineers and maintainers operating over the Bitcoin core code base. It actually is still a relatively divisive issue within the community where people acknowledge that quantum computers exist, but the question they're trying to face and understand is, well, how soon will it become a risk, an existential risk to Bitcoin? And that's where timelines have been proposed and have been edited and modified. And really what we've seen over the past 5 years is that what had started as, around a 2040 estimate for when quantum computers could break encryption, it has moved up pretty much every single year to the point now where, as of a couple of weeks ago, you have companies like Google, like Cloudflare. I mean, these are giant companies who are protecting really the world's internet infrastructure. Exactly. Yeah, they are.
We're setting a timeline for post-quantum cryptography migration to 2029.
Exactly. So that's a 10-year upgrade in the estimates for when we want to have, a quantum secure world. So I think that's really the piece to focus on, which is that these are moving timelines, and really every single year with the advance of technology and research, we're seeing these timelines bump up and up and up.
So let's back up here. Before we get into the engineering details, let's just talk about the bigger picture. What is the bigger picture bigger problem rather, you're trying to solve? How serious is this issue? In other words, why does your company exist?
Yeah. So it's a very large issue. Quantum threats to encryption, and by encryption we mean, whenever you send information over the internet, you want it to be secure. You don't want any eavesdropper to be able to read in on it or to capture it and hold in their own database, for example. So we're talking about securing the transmission of data. And the breaking of encryption is really critical, not only to, this industry, to crypto, but it's really practical to every digital transformed industry. And so when we're talking about the threats here, I mean, we're really talking on grandiose scale. And BTQ, our company, we exist to solve this exact mission. We exist to not only upgrade the world's mission critical infrastructure to post-quantum cryptography, but to do it efficiently as well, so that users and people, businesses, don't end up paying the cost for it. We can upgrade to post-quantum cryptography seamlessly and continue, business as usual.
And just explain to us how quantum computers can break cryptography at a high level.
Yeah, exactly. So when we talk about securing information, right? When we talk about encrypting information, we're talking about, let's analogize it to adding a layer of armor over some sensitive information. And all of this armor is really mathematically driven. We add this layer of armor that we assume a quantum computer basically can't solve some problem for in order to penetrate that armor. And the math problems that we've been using to date for the past 20, 30 years are all predicated upon this type of mathematics that, unfortunately, quantum computers have a known efficient algorithm for. It's called Shor's algorithm. Shor's algorithm is basically, it gives you exponential speed up in solving the type of math problem that we're using to secure our information. And when we talk about, exponential speed up, what does that mean? How can we think about that? Well, it's exponential speed up in the number of qubits that you have. So, let's say you have 2 qubits, 2 to the 2, 4 times faster. Yeah. Let's say 3 qubits, 8 times faster. Not that much, like 1,000 qubits, 2 to the 1,000 is a lot faster. And that's really the risk that we're dealing with here, which is that, we're reaching this maturity phase in quantum computing where we actually have viable pathways to building quantum computers with thousands, hundreds of thousands, millions of qubits. And the implications on cryptography mean that we can no longer assume that these encryption mechanisms are secure. We need to upgrade that to post-quantum cryptography.
It says here, I was reading an article here, and I'll just pull this up. This is from Caltech. This is theoretical. It doesn't say that it will happen, but it's theoretical. So the study Shor's algorithm is possible with as few as 10,000 reconfigurable atomic qubits was conducted at Caltech and Euratomic. The number of qubits, like you said, is getting increasingly smaller. What does that mean practically?
Yeah, exactly. So practically, it means that we need fewer quantum resources in order to break encryption. And this is sort of like quantum resources is the holy grail. It's what we've seen up until now, especially sort of characterizing up until 2024, was as you add quantum resources, and what we mean by that is, basically the amount of computing power that a quantum computer has access to. As we add quantum resources, their fidelity or their accuracy starts to degrade. And that was really the problem that had plagued this industry, the quantum computing industry, for the past several decades. Now we've reached this inflection point where back in 2024, Google demonstrated for the first time ever that you can have this, it's called an error correction code, but it's basically this technique to, as you add quantum resources, your errors actually start to flatten out, which gives you this sort of plateau in errors, which means that, basically once you reach that plateau of errors, any increase in quantum algorithms required after, or any sort of increase in quantum resources thereafter, is all seen as basically profit. We can take those for free. And that's where we're at right now, which is that we have these methods and these techniques to actually scale quantum computers to the point where they're actually relevant to us, and so we're faced with this dilemma of, okay, well, now we have hardware expanding and improving to a rate where we're beyond this plateau. And we also have advancements on the software side or on the algorithmic side, where Shor's algorithm was presented back in the late 70s. It was formalized later in the 80s, and since then, the number of resources that we've estimated we would need in order to execute Shor's algorithm has come down and down and down. So before you would need several hundreds of millions of qubits. In 2023, that was revised to 20 million qubits. In 2025, that was revised down to 1 million qubits. And then, as you pointed out, David, this Euratomic paper showed that we can get there in as few as 10,000 reconfigurable atomic qubits, which is fascinating, but also a little bit scary.
So let's bring this back to the markets. This is from CoinDesk, and in an interview with CoinDesk, John M. Martinez, Nobel Prize winning physicist, warned that quantum computers could break encryption within minutes. So I think it's a very well written paper. He is referring to a paper written by Google Research. It lays out where we are now. It's not something that has zero probability. People have to deal with this. So the paper outlines how a sufficiently advanced quantum computer could derive a Bitcoin private key from its public key, potentially within minutes.
Yeah. Yep.
Tell us how we can fix this or prevent this from happening.
Yeah. So So that's the key thing, right? When we're talking about quantum threats, quantum attacks to Bitcoin. We're talking about a quantum adversary being able to basically steal someone's private key. And if you own crypto, that's the number one rule. Don't show your private key to anybody. Don't you dare give it away, because that gives you access to all of the crypto that you hold. And so these private keys are really the root of this problem. If a quantum computer is able to steal your private key, that crypto is no longer yours. And so the way to go about this, I mean, it doesn't take rocket science. You replace the type of cryptography that is securing your private keys. And really what this is, pragmatically, cryptographically speaking, we're talking about changing the digital signature algorithm that Bitcoin and other blockchains use in order to derive private keys. And once we've achieved this, then we have private keys that are post-quantum secure, which means that we'll have private keys that a quantum computer can't just steal from you. It would need to break into your desk or your safe and steal your private keys the good old-fashioned way, physically.
If that were to happen, what happens to the price of Bitcoin?
Well, I mean, I think it's all value is predicated upon sort of the assumption that what you hold today will is also belongs to you tomorrow. If you had something today that doesn't belong to you tomorrow, what would its value be? It would probably be very, very low, especially as far as something as a digital store of value. I mean, this asset class has been seen as something that you can pass down between generations. And what we're seeing for the first time is that, that mental model is no longer true without post-quantum cryptography. It can be true if we quantum secure this. But I think the price of Bitcoin will be adversely affected with every milestone that we reach on our pathway to fault-tolerant quantum computing, where Bitcoin doesn't address these risks.
And importantly, the first Bitcoin to be potentially targeted by such a quantum attack would be early wallets like Satoshi Nakamoto's wallet, for example. And now, according to this Fortune magazine article, people have been debating whether or not the correct course of action is to freeze some of these early wallets. Where do you stand on this?
Yeah, it's a really interesting debate. So, we've said at the top that this quantum issue has been a contentious topic within the Bitcoin core community. There's no agreement in how to go about solving this. Some of the proposals that are on the table are, well, let's upgrade the protocol to a quantum resistant version where everyone who basically has a Bitcoin wallet, who owns some Bitcoin, can migrate to this, post quantum version, this post quantum secure version of their wallet. Now that works well if you have, an active Bitcoin wallet, if you have an active Bitcoin address, but it doesn't work well for addresses that are seen as lost or seen as, as you pointed out, Satoshi's original addresses, which have never been moved ever since pretty much creation. And this causes a really large problem because, there's a non-trivial amount of Bitcoin tied up in these addresses. We're talking about roughly 1 million or so. It's 1 point some odd million BTC that are tied up in Satoshi's lost addresses. And when we think about a post-quantum migration, if that, let's say everything goes swimmingly, miraculously, and we come to an agreement on how to upgrade the protocol, everyone follows through with that migration, which in itself is a massive overhead. Let's say we're able to do all of that successfully. We're still dealing with, 1 point some odd million Bitcoin tied up in addresses that could be stolen at any point.
Okay. Tell us about this paper that BTQ Technologies published. It's called Kardashev Scale Quantum Computing for Bitcoin Mining. Now, the Kardashev scale applied to Bitcoin mining, why is that relevant here? What is the ultimate result of this finding here?
Yeah. So this result points out exactly where we should be focusing our attention to, which is that, when we think about quantum risk to Bitcoin, there's, sort of two issues at stake. Often, I mean, these two issues have for a long time been conflated by sort of less technical crowds. That's fine, but when we look at when we look at the risk at a granular level, there's attacks to the private keys, which we had just talked about. And then there's also attacks to the production of blocks. So mining blocks in the Bitcoin network, where if a quantum computer was able to hijack the production of blocks, they could basically steer the chain in whatever direction they want and be able to carry out, for example, double spend attacks. That's why Bitcoin mining, the decentralization of which is so important to Bitcoin, because it prevents any one superpower from being able to gain control of the network and therefore be able to do anything that they want. And what this paper points out is that this latter attack, so the attack on the Bitcoin mining, is actually relatively, and I should say, it's really infeasible to carry out at current sort of Kardashev levels of civilization. And this comes back to something that Elon Musk talks about all the time, which is Kardashev scale computing, where there's this sort of framework for different levels of civilization that we have, where we're actually relatively inefficient. We're still harnessing energy from oil, and we're doing our best to harness energy from the sun, but it's we're not capturing it all. Kardashev 2 type or Kardashev 2 level civilizations are able to harness the entire energy output of a sun, which is something that we're very far away from doing. And it's really only at that point that we find that in our paper that we're able to basically break Bitcoin mining. You would need the energy output of a star in order to carry out a quantum attack on the Bitcoin mining protocol. And so what that does for us is it says, okay, well, we can simplify the problem then and just focus on that first issue of breaking private keys. We don't need to worry about Bitcoin mining. All of our solutions can, assume that Bitcoin mining will stay constant, which is helpful. You want things to remain constant in any sort of modeling and upgrade proposal. So we can just focus all of our attention to upgrading the post-quantum cryptography of these private keys that secure Bitcoin.
Okay, so just walk us through again at a high level how you're making cryptos more quantum resistant. Maybe starting with Bitcoin, since we were talking about Bitcoin. Yeah,
for sure. So, I mean, I think at this point we've articulated and we've gotten the point across that private keys are really the issue, right? This is where we need to be spending our time and energy. So, if we want to upgrade signatures or private keys, we'd be looking at upgrading the digital signature algorithm that is used to produce these private keys and public keys that everyone uses. So every time you create a Bitcoin wallet, you create a new private key, and then you have several sort of addresses that correspond to the private key. And what we want to do is to create a post-quantum secure version of that. The National Institute of Standards and Technology, which is basically the cryptographic standards body of the U.S. government, back in 2016, they solicited and evaluated a number of candidate algorithms for post-quantum digital signature algorithms. So they've been in this, they've been in this process for the past 10 years. And it wasn't until 2024 when they actually released and said they will standardize 3 different digital signature algorithms that are quantum secure. And so what we have now is, as of 2024, is a framework that we can use to go about upgrading the private keys, upgrading the post-quantum digital signature algorithms that can be used in a blockchain like Bitcoin, as well as blockchains like Ethereum, Solana, so forth. And so really what we're looking at is, how can we use and adapt these standardized algorithms that have been deemed to be secure not only by governments, but also international scientific communities, and harness them, use them in these digital asset block frameworks.
Okay, so what you're trying to do, correct me if I'm wrong, is you're trying to make individual private keys more secure. So it doesn't really matter what is in my private key. It could be an amalgamation of different blockchains and cryptos. As long as I secure it and make it more quantum resistant, basically that's your approach here.
So the approach is more at a protocol level. So we're actually looking at upgrading the physical code base of these blockchains. And every user who, as you said, you can hold tokens from different blockchains. Any blockchain that, or any user that holds an asset of a blockchain that has been upgraded to post-quantum will be quantum secure. So we're really, going for approaching the heart of the problem, which is the fact that these blockchains are insecure, and working at the blockchain level in order to upgrade them.
Okay, so just walk us through the process from A to Z.
Yeah. So, for example, what we did with one of the projects that we have running right now, which is Bitcoin Quantum. Bitcoin Quantum is a quantum canary network for Bitcoin. It says, okay, well, we know quantum is a risk. There's several technical solutions that we can put on the table, but instead of waiting around to basically reach social consensus to start testing these solutions out, we should just go ahead and build a canary network. So that's what we're doing right now. The way that we've approached this is saying, okay, well, take Bitcoin's code base. Bitcoin Core lives on GitHub and is publicly available to everyone on the internet. We forked the code base, which means that we just copied it into our own repository and started tacking on these post-quantum upgrades to each of the vulnerable components of Bitcoin. So anytime that vulnerable cryptography was being used, we went in and upgraded it with some NIST standardized post-quantum cryptographic algorithm. And what we have now is this live testnet, which is essentially the Bitcoin protocol, but a quantum safe version of it, where all of the vulnerable cryptographic primitives were replaced with post-quantum cryptography.
Which, I think, sectors, or I guess types of protocols do you think are most at risk if a quantum attack were to happen in the next, let's say, within the next 5 to 10 years?
Yeah, I mean, I think I think Bitcoin is probably the most commonly talked about one, but I think there's actually a very large chance that a quantum adversary would go after an entire financial ecosystem, for which we're seeing Ethereum and Solana start to form the base of. We're seeing a lot of institutional stablecoins, a lot of sort of traditional finance being on-ramped onto EVM and SVM based blockchains. And if hypothetically there was some adversary against the United States or against the sort of the Western world who had access to quantum technologies, Bitcoin would be a possible contender. But I think what they would be more interested in is disrupting larger scale financial flows and activities, for which these sort of programmatic blockchains like Ethereum and Solana would be prime candidates for.
And how difficult would it be to migrate existing blockchain assets to quantum secure networks?
So that all depends on the type of solution that we land on, right? As a community, as developers, engineers, as the protocol. I mean, ideally, it's as seamless as possible. We don't want every person to have to go in and upgrade their wallets. We're not going to be able to achieve that on a sort of mass scale. And so what we're looking for is ways to easily update this, and probably the easiest way to do that is by purchasing an asset. That's what sort of our entire industry is predicated upon. And so by being able to purchase basically a new asset that is quantum secure, you would be creating a hedge for yourself, be offsetting the risk of any quantum attack on some non-quantum secure asset that you hold.
The first entities or individuals that come to mind, obviously whales who hold a large amount in their private keys, as well as exchanges, prime targets for any such attack. How are these individuals and entities approaching this issue right now? Yeah,
so we've seen a lot of, so again, coming back to the institutional angle, we've seen large ETF and sort of custodians of Bitcoin and ETH start to become very vocal about this. We saw several ETF managers come out and publicly state, if Bitcoin doesn't get its stuff together, we've been here before Bitcoin, we will be here long after. We will, we'll divest. So they have become very vocal about this issue. What we're not seeing yet is a formal sort of coalition of post-quantum upgrades come around Bitcoin. We have seen such a coalition come around in the Ethereum ecosystem, where the Ethereum Foundation, at the beginning of this year, launched their own post-quantum task force. The same has yet to be seen for Solana and Bitcoin, which is, I mean, there are conversations going on in the background, but certainly we haven't seen the level of coordination that would be required for either of those two ecosystems yet.
So let's say a Bitcoin treasury company were to approach you and say, hey, Chris, help us approach this issue. Help us at least think about it. What's this conversation going to look like?
Yeah, well, there would be one part of the solution where we say, okay, well, if you want to protect your Bitcoin, you can do so through a number of measures so that your Bitcoin isn't stolen. That would be through a combination of both hardware and software solutions that are available on the market today, both of which are companies involved in the production of. But there would be the sort of larger overhanging issue of, okay, even if let's just say ETF holder holds 1,000 Bitcoin. Even if we're able to protect that Bitcoin from being stolen from them, the value of which, as we talked about at the beginning of the show, will be adversely affected as long as the protocol doesn't upgrade or doesn't have any feasible migration path. And so it's really that it's one thing to protect the Bitcoin itself. It's another thing to protect the value, and protecting the value is much harder. That will require a protocol upgrade, for which we have in our arsenal this Bitcoin quantum network, where it can essentially serve as a quantum hedge to any existing sort of prior quantum vulnerable assets.
This is an interesting article that I want to bring to your attention. So it says here, why your encrypted data from 2019 is already compromised, the quantum time bomb. This was dated a couple weeks ago. A major financial institution encrypted a merger agreement in 2019. The encryption was state-of-the-art RSA 2048. The key was properly managed. The implementation followed best practices. Security auditors signed off. Compliance teams approved. The encrypted file was transmitted over TLS, stored in an encrypted database, and backed up to encrypted archives. An attacker intercepted that encrypted transmission in 2019. They stored it. They're still storing it. Yeah. And they can't decrypt it today. But in 2032, when quantum computers become powerful enough, they'll decrypt it in minutes. So the issue here is that hackers already have our data in storage. They just can't access it, but soon will. So how does your company or BTQ, or anybody working in this field approach this issue that, look, our data is already compromised. It's only a matter of time before it gets accessed?
Yeah, exactly. Yeah. So, I mean, that's the classic harvest now, decrypt later problem. Yeah. And it's a very real issue across every digital industry. The way that you can predict the best way to go about protecting against that is by migrating over to post-quantum cryptography today. Because again, there's no backward mitigation solution for harvest now, decrypt later. As long as you're using vulnerable cryptography today, some adversary, someone on the internet will be able to store it and decrypt it later. And so really the most pragmatic way to resolve that would be to migrate as soon as possible.
But by someone, who are we talking about? Are we talking about nation states, or will computers become powerful enough that this could be done on a laptop? Yeah,
so it could be anyone at any sort of level of the internet stack. Right. So if for example, for Bitcoin holders, that's a very, user centric demography where, you're in charge of your keys as long as you sort of follow the self-custodial protocol. You own your own keys. And so therefore you're in charge of the cryptography that you use. So you can do that, at an individual level. We've seen already Google and Cloudflare come out and publicly state, their PQC post-quantum migration timelines are aimed at 2029. And so they'll be doing it for their customers and all of their platforms and services by 2029. And then of course, we've seen, as we talked about, the National Institute of Standards and Technology come out and standardize these algorithms for not only the government, but also, businesses around the US. Their own, for example, the Department of War, previously Department of Defense, they've come out with an internal mandate. This is a memo released in November 2025 about their own timelines for migrating to post-quantum cryptography as soon as possible. And they've set an internal date for 2030, which has likely been revised ever since these recent announcements from Google. And so, we're really seeing this across the stack. It's, individuals, companies, and governments across the board need to be able to migrate to post-quantum as soon as possible.
This article further highlights the urgency here. This is using a formula they called Moscow's theorem to determine the urgency of migration to post-quantum cryptography. X plus Y greater than Z, meaning migration is urgent. I'll simplify this for most cases, the calculation X being 10 years, Y being 20 years, Z being 8 years. The conclusion is that not only is it urgent, it's already late. Inventory, for example, we have full enterprise rollout is 24 to 48 months.
Yeah.
And when you see, let's say you agree with this calculation, when you see a number like that, what should be done at all levels? Government, nation states, enterprises, individuals. If we're already late, then what's next?
Yeah, so I think the easiest way to go about that is is thinking about how long do you need your data to remain secure for, and so if it's your private keys, you want it to remain secure for the next 30 years, let's say hypothetically. If you think a quantum computer comes in the next 30 years, you're done. You're toast. And so really, it starts by thinking about what type of data do we want to secure, and how long do we want it to remain secure for? If any of the timelines for predicting when quantum computers come onto the scene overlap with that data sensitivity period, your best interest is to migrate to post-quantum cryptography.
So tell us a little bit more about how BTQ Technologies fits into the picture. Practically speaking, what is the type of work that the company is doing right now? And what is the revenue model? Investors might be curious to ask.
Yeah. So in a nutshell, we provide post-quantum cryptographic services on both hardware and software. So we build what are called secure elements, or you can think about it as a security chip. It's the device that goes into your phone or into your car, into a device anywhere in the field, in order to be the cryptographic security module within that device. So we perform all of the encryption. Our goal is to be able to roll this out into the mission, basically those industries that we see are the most mission critical, starting off with things like automotive, defense, and really sort of IoT sensor based in general. We're seeing 3 point some odd billion devices, embedded devices being launched into the field with classical security, and these all need to be upgraded. And so we're taking a very pragmatic approach in building basically it's an ultra efficient and a reprogrammable security chip, which means that it is able to consume energy at a dramatically lower overhead than what all the security chips are consuming today. This is perfect for embedded devices that live on a drone, for example, or that might go up on a satellite, and as well as it being reprogrammable. So, as we sort of face these different quantum attacks in the future, it'll be very likely that we'll want to upgrade the security chips and the algorithms on these security chips. Something that's being done today is, the way that security chips are being built today is that they don't allow for you to do this. We've been operating on the same security algorithms for the past 2 or 3 decades. And so this is a bit of a novelty to the industry, where you can actually have a reprogrammable security chip that gets deployed again onto a satellite where it needs to live and be secure for the next 30 years, and can update on the fly as these algorithms change. Yeah.
Okay. Well, the project, the company sounds very interesting. Well, what's the next milestone for you right now?
Yeah, so we're in the process of rolling out this hardware. We're validating this technology with ITRI, which is the company who incubated TSMC. We are, as we said, we're rolling out this Bitcoin quantum network, which acts as effectively a quantum canary network for quantum risk to the Bitcoin protocol. Both of these are going. For the Bitcoin quantum network, we're going to be likely seeing a mainnet sometime this summer, which gives people, a physical, pragmatic way to go about addressing the quantum risk for their own personal livelihoods, which is, having an asset that they can trade in order to sort of offset any risk that the Bitcoin core protocol does not upgrade. Simultaneously, deploying this hardware under the field, which gives people and businesses and companies a real solution that they can use in order to initiate this post-quantum migration.
Well, congrats on the work that you're doing so far, Chris. Tell us where we can find more information about the company and follow your work.
Yeah, so you can keep up with us at btq.tech, BTQ Technologies on Twitter, BTC Quantum on for the Quantum Canary Network, and it was a pleasure speaking with you, David. Thanks for having me.
It's a pleasure to have you on the show, Chris. And we look forward to the developments of the company. Thank you very much for watching. Don't forget to like, subscribe, and follow BTQ Technologies. Links down below.